When we are defining a watershed or trying to identify streams in an area we're not familiar with, ArcGIS has a bunch of tools in the hydrology toolbox and the spatial analysis toolbox that allow us to do so pretty easily. So I went ahead and, for simplicity, made the steps for our watershed analysis into a model, which I know is hard to see here, but regardless of the watershed you're using, you're going to be following a couple of the steps every time. If you want to create rivers, you may not want to do that every time, but we'll just go through with similarly to what the lab does. So let's start at the start. So first off, we have our input DEM. This is our digital elevation model. And right now we're looking at it. It is for just east of Salt Lake City, so the mountains around Salt Lake City. Let me just activate this real quick. So we are saying that our first step is our fill tool, which you remember from Canvas. This is a tool that's going to get rid of all of those unnatural sinks, or natural sinks if you have them in your area, so always make sure you have it. And then in the output from that, once we have the depressionless DEM, we'll be able to start calculating where each cell is going. So we can zoom in, let's get close. So our 30-meter DEM, we can start to see as it pixelates, we could look at like this cell here. We could look at this cell here and start to determine what its value would be, if it would be, or which direction the water would be flowing. So if a drop of water hit this exact cell, which way would it go? Which is the direction of steepest downward descent? We then move, so to recreate our flow direction, where do we go next? In the lab, the next thing you would do is start creating your flow accumulation. So you want to start thinking about where your rivers are flowing. So our flow accumulation tool is going to calculate how many cells, so how many of these 30-meter cells are flowing into each other cell. So if we know this cell is flowing south, let's say this is the rate of steepest downward descent, this cell to the south of it, which you can kind of see here, this cell to the south of it, we know would have at least a value of 1 because it's one cell was flowing into it. And if it flew down here, this one would have a value of 1, and this would be accumulating 2 cells. So 1, 2, put a 2 in this cell. So that's all that our flow accumulation tool is telling us. We can then use our con tool because we'll get our flow accumulation, and it may not be really easy to read or be perfect. So we can use our con tool or our conditional argument tool, where it allows us to define what value of accumulated cells equals a stream in this case. And you can use it for watersheds too. So let's say, like in your lab, you're going to start with a stream, you're going to start with a value of 10,000. So that's saying that for each cell, for a cell to be considered part of a stream, it has to have greater than 10,000 cells flowing into it. So that means if we wanted this cell to find out if either of these cells were part of a stream, they would have to have 9,999 other cells flowing into them. And then the output for the con tool is coded 0 and 1. So you'll see that in there. The 1 being anything that is a river, so it's a binary, like true, false. 1, river, yes. Part of a stream network, yes, 1. Everything else will be 0. So you'll get a black and white sort of spooky stream network from there. From there, we'll just create them into actual streams. We'll use that to create a polyline or a line layer. We can then do a couple things like figuring out the longest flow in our river network. So we can use our flow length tool, and that's just using the output from our flow direction. So we kind of use this output a lot. We're also going to use that in our basin tool too. So the basin, this is where we start defining our watersheds. If you remember from Canvas, there are 2 tools that help you define watersheds. One is the basin, and I'm blanking on the other one. This is the one that requires less input from you, so you do not need to have the pour point. So that's what we're doing. We don't know the Utah area very well. I don't know the Utah area very well, so we're just going with known values. I'm sorry, we're just going with basin because it will calculate where it thinks the poor points are for us. And then at the end, we're just creating polygons from our raster output of the watersheds. So let's go ahead and we'll save our model, save our project because it crashed on me a bunch. We'll go ahead and let's zoom out so you can see that whole model. Go ahead and run. So now that we can see that my model has successfully run because all the drop shadows are on the output, so I'm just going to quick save everything before it all crashes. And we can start adding our output in. So we can look in our Utah database and we can see all of our outputs that we've created. So our watershed, Utah watersheds, streams, and then some of our outputs as well. So let's zoom out a bit. And we can start adding them in from our model. Come on, model, where did you go? So we can start with our fill, our depressionless DEM. So you can see it's not going to be a ton different. The high and low values haven't changed. That probably was already filtered, but that's okay. We'll add in our flow direction. We can start to see some of those cool values that we get from this crazy way it looks. We can see that some of these areas look pretty flat or have a pretty shallow slope. They all have that same bright green. But we can start to see with the flow direction the defining of some of the ridges and valleys and maybe some streams. So let's go and add in our flow accumulation. So let's back out of here. So we also have to change the way this is displayed. I may have just screwed this up. There we go. So we can start to see the essence of some streams here. They're pretty light. Let's see if they're connected. They are connected all the way through. We can do, it's not really letting me do, but we can, we don't want to do, we want to do classified. We want 2 classes. Well, I'm just going to leave it as it is for now, because it's not worth fighting with. But we can start to see the stream network. So we could go back and rerun this tool and change the con to be more or less if we wanted more definition, more rivers displayed, but we have a lot in there. Or we could, so we could decrease the value to see more, or we could increase it if we wanted to see less. Like we didn't necessarily want to see these itty bitty reaches of stream way up here. Okay, so flow accumulation con, that was our, and then our streams output. And we can see when we change the color here. Turn this off for a second. We can start to see those streams. So something weird. We can definitely see the flat lines here, or the flat part of the lake here. But we could go back and adjust up our 10,000, and that might get rid of some of these. Let's bring that model back up. Okay. So then our flow length output, we can find out the furthest distance water had to travel from one point to any point on the raster. So you can see further distances are in the lighter colors, shorter distances are in the darker colors. So you can see there's points of water traveling from here essentially to out over here. That's not what I wanted to do. And then last up, we'll add in our basins. and then I'll add in the polygons for that too. So we can start to see there's one big basin here. You can see where that really long flow line was, traveling all the way across here, and some of the smaller ones. You can see what it looks like turned into polygons. There are always some weird things that happen on the edge, but just for this demo, it's fine for now. We can compare this to our known watersheds. You'll see it's going to look a lot different. Yeah. So see, just comparison, a lot more watersheds that they found in reality. This is kind of giving us that big overview and of all the different watersheds in Utah. Turn that up. And when you look at ours, it's obviously going to be a much smaller area, but it looks like we're looking at some of the larger basins versus some of these teeny tiny small basins. Something we can look at to adjust as well. But that is a general steps through watershed lab.